Hello everyone, I am Sari. Welcome to today's session on Kubernetes supply chain security. Uh, in this session, as you know, I have already pulled up this page from Digital Ocean official uh, documentation, community documentation page. So we'll explore like how we can harden the how we can harden the control plane and worker nodes, how you can secure your Kubernetes application and environment, and how you can protect software supply chain. So as we go through this documentation, this article, uh, we'll explore, as I mentioned, Kubernetes best practices, how you can protect your cluster, and also dive into practical like tools like Snake and Kubescape. So before demonstrating like how they can enhance your security posture through vulnerability scanning and all, let's understand typical architecture of Kubernetes cluster and understand possible weak points. So we have control plane. So it is responsible for managing cluster workloads and ensures desired state of your application. Where we have got like HCD, which is also for storing your key value stores, key value pairs of cluster data, which is connected via Kubernetes API server, and responsible for is a kind of entry point for all cluster operations via REST APIs, and which you can connect it by connected to Scuttler. Scuttler is responsible for assigning ports on each worker node, whereas Cloud Control Manager is a responsible for managing the like cloud specific API uh, controllers. So as is again connected to cloud provide API, so as it is via communicates with digital voice and load balancer and digital voice and object storage. So where load balancer is responsible for like uh, you know uh, distributing the traffics to across ports, and whereas block storage for storing uh, your uh, something related to your database, right? So maybe it is your files or something is related to your images and all. And with that, we have a worker node where it's like Kube proxy is responsible for handling networking. We have got Kubernetes is responsible for running your ports, ensuring your ports running on node. So we have weak points like HCD and Kubernetes API, so vulnerable to attacks if exposed publicly, whereas Kubernetes also like vulnerable to attacks if exposed publicly. So like as we know, like the digital ocean is something like it is a kind of Kubernetes managed service. So managed Kubernetes service that lets you deploy Kubernetes clusters without dealing with the complexities of installing and managing control plane components and containerized infrastructures. So let's understand like from this like control plane hardening where like you make sure like you secure the REST API, the Kubernetes API with authorization, authentication, TLS encryption, like yeah, make sure like your authentication is not set by anonymous, or your authorization is by default like always allow. So it should be treated to be like like we have to make it authentication by default, and like authentication via anonymous to be false, like that, and make sure the have this in your cluster configuration like for the Kubernetes API server, and regularly update the OS kernel libraries. When there is some release happens for Kubernetes versions, make sure you update those versions to minimize your risk, like to get it like low, and to fix vulnerabilities, right? Use firewalls and network policies to minimize external access. You can use deny policy, allow policy for only necessary services, and do not expose HCD database publicly, as we mentioned, and limit access to critical components. And talking about working node hardening, avoid exposing kubelets or kube proxies publicly. Restrict public SSH access. Use VPNs for system administration. So yeah, I think this is something related to that. Okay, now, like application environment hardening, like you can scan YAML manifest for misconfigurations, and set a strict permission for ports. We can use some kind of immutable file systems, root file system, like root access to like not to users, right? And you can maintain kind of, you can using some kind of for security standards, configure RBAC policies properly, and assign container images to ensure only trusted ones. You can use cosign tools like that. Use admission controllers to allow only signed images. For example, you can use Governor, where it's like allows to write policies. We can apply this on a cluster basis, which will, will not allow those images which are not signed. Apply network policies, as I mentioned, namespace isolation to control traffic, and probably scan the Kubernetes cluster. So we'll definitely look into that in our demonstration uh, when we come to that. So uh, let's view understand something behind that. The supply chain security scan. Make sure you scan application source code and third-party libraries for vulnerabilities. Regularly check content images for known securities. So it is now talking about the process of we can ensure end-to-end security for Kubernetes. You can see like we have Git as a source, so source of truth, where we write the code, we manage the code, and push the code, and where after that, like configure the whole infrastructure. Sometimes we write deploy to Dockers for containers, and we also pull the image from Docker. So make sure you sign your image, as you can see here, like sign your image and push, and you can pull that image for your application. And you can, like make sure you create ingress controller to create your ingress gateway, where like you can manage your firewall, and also you give the logs, user access logs to not to like everyone, but make sure to specific users. You can maintain your ongoing scans, and also image admission control and other things like audit logs and all. So in case of DOKS, you don't have to worry. As I mentioned, it's already taken care by cloud provider. And so yeah, uh, so we can also look for like other tools like scanning, vulnerability scans within your CI/CD pipelines. Like you can use Tecton, Jenkins, GitHub Workflows, where you can integrate those tools uh, to process those scanning, like predictably running scans within your Kubernetes cluster, evaluate security risk, and take the appropriate actions. So this is all about thing, I think, and like before using that, I think you make sure like you install Snake tool and Kubescape. So we'll go one by one. Let's start with Snake here, the Snake vulnerability scanning tool, and we will dive into, like, it is, yes, it is open source, so you can use it for any purpose, like No need to worry about cost and anything like that. Pricing, it comes with the community edition. I'm not sure, but yeah, it has to be like that. So you make sure like install the CLI from the documentation based on your environment, right? So OS architecture and all. So I have already got it installed. I don't have to worry about like installing again. So as I can show you my versions right now, uh, it's 1.1294. So scan your project code from your current directory. So let's go to my code, my repository, and run this. Uh, paste subcommand to see how this works here. For known issues, 10 issues, and 57 vulnerable paths. So here you go. So I think it is giving you the possibilities of high severity vulnerabilities found in few of the libraries which I am using for this code. So this few are like medium severity vulnerability found here, and yeah, that's it. So what you can do is suggesting us to uh, to make sure. Let me make it bigger. Right, to make it upgrade this version to probably in this among these versions, and here you go. So basically, as it has to go with the code. So when package your code, we containerize your code, your application, make sure you have like that no vulnerabilities, no any kind of vulnerabilities on your code.